Okay. Good morning. My voice is audible?
Yes, sir.
Okay. Thank you. So during the last lecture, we have seen shock absorber, then reaction members in that radius rod, stabilizer bar, and what are the functions of those reaction members. Now, this topic we have started during the last lecture, that is Hotchkiss and torque tube drive. So based on how torque, driving torque and braking thrust, which is beared by various elements in the suspension system. So these two types are there. So this one is Hotchkiss type, or generally it is called as a Hotchkiss type propeller shaft, and this one is torque tube type propeller shaft. Now let us see one by one. So this one is Hotchkiss type propeller shaft. So you can see figure on the right hand side. So this one is frame of the chassis, or simply one of the longest member in automobile chassis frame. Then this one is gearbox shaft. So whatever output shaft of the gearbox, which is shown here. This one is the propeller shaft. Here universal joint, here universal joint, and only here bevel pinion shaft, and which is connected to this rear axle casing. So that is final drive inside this. This one is the spring. This is the wheel. This one is shackle, and this is the front anchor. So with respect to this, so this is simplest and most widely used type of rear axle drive. So wherever front engine rear wheel drive is there, in that case, this is commonly used, or simply simplest one type of rear axle drive. So here you can see that this is the spring, that is lip spring, which is connected to the bracket, and here it is a shackle which is compensating change in the length. Whatever change in the length of this lip spring, that has been compensated by this shackle. So in this case, the spring, besides taking weight of the body, also take torque reaction and driving thrust and the side thrust. So how it is facilitated? Just by connecting one bracket at the front end of the lip spring. So if we need to see the two figures. So here, this one is the first one, Hotchkiss type, and here this one is torque tube drive. So this is the simplest one. Here, the function of spring, or function of the spring, is to take weight of the body, also sustain the torque reaction, also provides driving thrust, and also sustain the side thrust. That means when the axle is rotating, traction is available, the tractive effort is available here, and that tractive effort via this section will be given to this bracket, and again that is given through this long member of the chassis to the front wheel, so that vehicle will propel in the forward direction. So here you can see, for understanding the difference, so propeller shaft is provided with two universal joints. So at this end and at this ends, along with one sliding joint that is not shown in this figure. So here, this is the spring which is rigidly connected at the middle part of the rear axle, and at the front it is connected to the bracket. So whatever discussion I have made, and this one is the bracket. The front end of the spring is rigidly fixed on frame while the rear end is supported in the saddle. So to have flexibility to accommodate length, that is supported with the flexible joint. So further, you can see what is the function and how it is providing that driving and sustaining the braking torque. So driving and braking torques are took up through the front half of the rear leaf spring. So already this one is the front half of the leaf spring. Driving and braking torques are taken by the front half of the leaf spring. So then the driving torque and braking torques are took up through the links and arms when used with the coil type of spring. So this is related to the leaf spring suspension, and this is related to the coil spring suspension. So that is the difference between that coil spring suspension and the leaf spring suspension. So with respect to this Hotchkiss type of propeller shaft, you should remember the driving and braking torques are took up through the front half of the rear leaf spring. So that's why here bracket is used and this end is rigidly connected to the bracket, wire bracket to this side member. So here the torque transmission, whatever tractive effort available at this point, so differential, then the housing, so inside this differential, then this casing, then leaf spring and the frame. So in this way, vehicle is able to propel in the forward direction. So this section is used to transmit the torque. So that's why here there is a rigid connection and here there is a rigid connection. So this is the main difference between Hotchkiss type and torque tube type. Now let us see what is torque tube type of propeller shaft. So here you can see how it is constructed. This one is leaf spring. This is frame or long member of the chassis. Here, just by visualizing, you can understand this one is the saddle, this one is saddle, and this leaf spring is mounted on the casing. And here there is differential housing. And here it is mentioned as a torque tube. That means it is a tube inside which propeller shaft is going to rotate. And this is the cup which holds one end of the propeller shaft. And this is the output shaft of the gearbox. So just one small figure is shown here which will detail what is the cup. So this one is the cup inside which there is universal joint. This is the propeller shaft and this one is the torque tube. So by name itself, you can relate this one is the torque tube and inside which propeller shaft. So what is difference between that Hotchkiss type and the torque tube type? So you can see, so in case of torque tube type of propeller shaft, a tube is provided that covers the propeller shaft. A torque tube is a large diameter tube fastened securely to the rear axle housing and which completely encloses the propeller shaft. Right, so like that it is constructed. So here the function of suspension spring is to take up shocks and impacts only. So whatever suspension spring, they are not going to take part in transmitting the driving torque and sustaining the braking thrust. So in the previous case, what we have seen, so that front end is rigidly connected through the bracket. So half part which was taking part in for the braking thrust as well as the driving torque. But in this case, what is the function of the spring? That spring is going to take only shock and impact only. It is not taking any part in driving torque and the braking thrust. So here, so whatever engine power, so already that is known to us. So engine power transmission takes place through the propeller shaft. So braking and acceleration causing sudden torques, those torques are taken over by the torque tube. So this is the tube which is connected to the cup, which is connected to the axle casing. That means this casing or this tube is going to take that braking and acceleration, the torque caused by the braking and acceleration of the vehicle. So you can compare these two figures so that you will understand what is the difference between these two. So this one is Hotchkiss type and this one is the torque tube. So at both end of the leaf spring, there is shackle. That is one major difference. Here, propeller shaft has to rotate and has to take part in driving thrust as well as driving torque and the braking thrust. Here, this torque tube is taking that whole function, and this leaf spring is to absorb, has to absorb the shock and taking part of impact. So this way there is a difference between the Hotchkiss type and torque tube drive. So you can see based on the application, so majority of the vehicles nowadays, they are using this torque tube type of, sorry, Hotchkiss type of propeller shaft. Okay. So one more part is remaining, that is air suspension system that we are going to discuss. So just to see the schematic of air suspension system. Now let us see what are the various components of air suspension system. So already we have seen previously air springs, but I got one of the good figure, so that's why I have added this slide once again. So just you can see this one, that is arm, and on the arm there is wheel, and this point B, at this point B, this arm is hinged. So this is part A, which is piston rod. Then this one is C, total part, and it is called as a lever. This 5 or V means cylinder. So, and it forms lower part of the suspension unit 2. So this second part, that is the suspension unit, which is hollow circular portion separated with the diaphragm. So upper part is filled with compressed air, and lower portion, that is under the diaphragm, which is filled with hydraulic oil. And this fifth number component, that is the pipe, and that will modulate, or that will alter the springing rate. So by providing the hydraulic oil, so we can change the springing rate, which can be increased or decreased depending upon the load and the road condition, just by increasing or decreasing amount of oil inside the cylinder 5. So this is the air suspension system component. So in detail I have shown. So already we have seen previously. Just that figure I will show this way. Here it is. Okay. So in the same way, you can see this one is the actual image for that. This is air suspension system. The same is provided. This one is the schematic diagram. Okay. Now let us see what are the advantages and disadvantages of air suspension system. So it has reduced noise, reduced vibration, and reduced harness. And the vehicle having air suspension system, which will have better fuel economy. So again, it is more costly. That will be disadvantage. Then its operation is more complicated, and there is question related to its durability. So those are some of the disadvantages with respect to air suspension system and its component. Then some of the photographs regarding suspension system. This is conventional one, that is leaf spring based suspension system. You can see this one is the shackle, and front end is not visible, but it is connected with the help of bracket. This one is the rear axle. This is differential housing, and this one is the suspension system having coil springs as a element for absorbing the shocks or for taking the impact. So these are the some of the photographs for the suspension system. Now, part B of this unit that we are going to see. Just I will share PPT related to that. Wait for 1 minute. Okay, screen is visible. Milind, screen is visible.
Yes, sir. Visible.
Okay, okay. So part B from this unit number 6, that is modern trends in automobile. Okay. So first important unit, which is nowadays part of modern automobiles. So that is electronic control unit, and in short it is called as ECU, or sometimes for whatever control unit used to control the engine operation, so that is also called as the engine control unit. But with respect to this, whatever image I have shown, so this one is electronic control unit with engine sensor. So what is this ECU? So this one is a device that controls all the electronic features in a car. So its a function is to control all the electronic features in the car. So ECU or electronic control units are one of the most important parts of the vehicle in the modern vehicles. So based on different features, so in a single car there will be multiple electronic control units, and those are required to control multiple parameters. So this one is the schematic. So whatever image we have seen, so this one is the image, and in actual such circuit is provided, which includes various types of sensors. So you can see this ECU 32-bit that is mentioned there. Then EGU ESS, CPS. So all the nomenclature is shown here. So this ECU consists of various sensors. So here you can see EGU, EGO, that is exhaust gas oxygen sensor. Then MAP, so you can see MAP, that is manifold air pressure sensor. Then VS, that is vibration sensor. So here vibration sensor, it is connected to this ECU. So whatever electronic control unit, one unit to which all these sensors are connected. Then another one sensor, that is CPS, that is crankshaft position sensor. Then DS, that is detonation sensor, it is related to the engine. Then ESS, engine speed sensor, whatever sensors in this area. Then TPS, throttle position sensor. So you can see this one is the throttle, and here TPS. This one is carburetor, engine vacuum sensor. Here it is shown. Then air intake temperature sensor, AIT. So air and fuel mixture is provided to the carburetor, and function of carburetor is to atomize. That atomization will affect, so whatever quality of atomization that affects on the generation of the power. So these sensors are used to then humidity sensor, HS, then engine vacuum sensor, EVS. So this may be asked in multiple choice question during final examination. Then ACS, that is air conditioning sensor. Then FS, force sensor. So here you can see. Then EGR sensor. Here EGR valve, one of the important component. Then coolant temperature sensor. So here there are various features, and for that there will be different sensors. So what are the features which are included? Again, whatever additional features such as temperature control inside the cabin, then controlling the braking action, then providing different springing rate with respect to the suspension. So for all these there will be sensors. So for some of the vehicles there are multiple electronic control units, and in some of the vehicles there will be one controlling unit that will control all the features. So this already we have seen. Then this is, we have seen. So whatever vehicles having multiple ECU, they are divided on what task they perform. So whether it is related to the braking action, whether it is related to the suspension action, whether it is related to the comfort of the passenger, whether it is related to the speed, whether it is related to the transmission. So based on that, these electronic control units are divided. So first one is engine control module, which is also called as ECM. It is having various sensors, and this ECM is going to ensure the amount of fuel and ignition timing necessary to get power and economy out of the engines. So with the help of this engine control module, that is ECM, we can ensure the amount of fuel and proper ignition timing to have economy or fuel economy with maximum power. So this is one of the one of the control module related to the engine. Then another control module, that is a brake control module. So we are discussing about multiple electronic control units. Okay, so brake control module, so used in vehicles with anti-skid or anti-lock braking system. So this brake control module makes sure that wheels are not skidding. That means they are going to avoid locking. They are going to avoid wheel lock and determine when to trigger braking and let go of the brake to ensure wheels don't lock up. So this brake control module will be part of anti-locking braking system. So it is also consisting various sensors and some of the electronic controls. So that's why it is also one of the electronic control unit. Then next one is transmission control module, TCM. So transmission control module, that means it is related to the gearbox, related to the transmission element, related to the speed, related to the acceleration of the car. This transmission control module ensures about smooth shifting of the gears just by sensing the engine RPM and the acceleration of the car. What it means? Whatever components which are directly related to the propelling of the vehicle, such as axle, wheel, the speed is sensed by the sensor. At the same time, it will sense the speed of engine, that is engine RPM. Accordingly, it will modulate the signals via this electronic control unit provided for transmission control. We can have smooth shifting of the gears as per the requirement of the torque. Then another one control unit that is called as a telematic control module. So it can also called as a telematic control unit, which ensures so whatever onboard services, and it controls satellite navigation, whatever internet, phone connectivity of the vehicle. So all these satellite navigations, then internet, then phone connectivity are the part of this telematic control module, which is coming along with all the modern cars. So that's why it is included in the modern trends in the automobile. Similarly, there is one of the unit which is used to have control with respect to the suspension system. So suspension control module, that is SCM, and presently it is used to provide active suspension system. So depending upon the current, depending upon the nature of the road, depending upon the type of road, whether it is vehicle is moving in hilly terrain, vehicle is moving on rough road, so it will ensure the correct ride or correct ride height, and accordingly it will provide optimal changes to the suspension system on the driving condition, that is nature of road, hilly terrain, rough road, road with sand, road with mud. Accordingly the system, there will be optimal changes in the suspension system, and the end aim is to provide comfort to the passengers and goods. So such electronic control units are the important component of the modern automobiles. So multiple ECUs are there. Now let us see one of the examples or one of the operation which comes under this electronic control unit. So how does an ECU works? So such type of ECU, so generally you can consider it is one amongst the 5. So just we will see by taking one of the example. So you can see, so working of an ECU is actually not complicated as one might assume. So whatever we are assuming that it is somewhat complicated, but it is very, very simple. So just it is an electronic device which has base numbers and parameters filled in its memory. So it is related to the electronics. So whatever base number and parameters filled in its memory, having multiple sensors that will feed data to that ECU. So, and this ECU is able to provide orders or giving order to improve their output. So based on whatever input, that is again based on the condition or the situation of the vehicle, And you can take one of the example by means of which you will able to understand how this electronic control unit related to the deployment of airbags during an accident. So let us take one example how ECU controls something by looking at how airbags are deployed during an accident. So there are sensors. So the car has sensors located around itself called crash sensors. So whatever type of sensors are required to deploy or to give order for deployment of the airbags during the accident, such type of sensors we are going to call it as the crash sensors, which inform the ECU when a crash has occurred. So the ECU then measures the speed of the vehicle when it undergoes accident, and then using onboard memory compares the data of whether it should launch the airbag or not. So based on the comparison and whatever data stored in that the memory, it will intimate, it will give order, that ECU will give order for deployment of the airbags. So once that comparison is done, or if the data provides enough reason to deploy the airbags, then this ECU, electronic control unit, will deploy the airbags, and whatever passengers inside the car or the automobile, they will be safe. So this electronic control helps to do all these things in mere millisecond, just by sensing the speed, comparison, whatever stored in the memory. Based on that, it is able to deploy the airbags and start inflating those airbags so that to have safety of the passengers. So this is one of the important use of electronic control unit based on the feature. So you might have heard 2 airbags, one for the driver, one for the passenger near to the driver, or for some vehicle it is for some vehicle, for some optional models it may be up to 8, 10 like this. So with increasing the airbags, we can have more safety with respect to the modern automobiles. So this is about some of the information, brief information regarding electronic control unit, which is essential component in nowadays vehicles. So based on the features, its number can be increased, that we have seen for engine control unit, control module, then brake control module, then transmission control module, telematic control module, and suspension control module. So we have seen the airbag deployment during an accident. That is one of the operation, one of the function of the electronic control unit that we have seen. Okay. So in next lecture, I will take another trend in the modern automobile that is related to the electrical vehicles with respect to the battery and with respect to the fuel cell and some of the features in the hybrid vehicles. So that we are going to see in the next lecture. So please wait for 1 minute.